Hello friends, today we are going to see the topic inverse of the matrix, right? But before going for that, we will see what is meant by the matrix. Matrix is nothing but it is an arrangement of numbers in the form of rows and columns. Depending upon the number of rows and columns, we can categorize the matrix in different types, say square matrix, rectangular matrix, row matrix, column matrix, then identity matrix, scalar matrix, then diagonal matrix, and symmetric and non-symmetric matrix, singular and non-singular matrix. You already know all these things. Now today we will see how to find out the inverse of the matrix. There are two methods to find out the inverse of the matrix. One is by adjoint method and another one is by inversion method. So we will see first what is the definition of the inverse of the matrix, right? You know that there is a additive inverse for the natural numbers, that is if 3 is the number, then its additive inverse is -3, that is 3 minus 3 is equals to 0, whereas its multiplicative inverse we write it as multiplicative inverse of 3 is 1 by 3, so that 3 into 1 by 3 is equals to 1, where 1 is the multiplicative identity. Now for matrices, identity matrix is the identity we get. So we define the inverse of the matrix as if A and B, these are the two square matrices of order n, that is if A is n cross n matrix and B is n cross n matrix, then we say that if AB is equals to BA is equals to identity matrix, that is if you multiply A with the matrix B or B with the matrix A and we obtain the identity matrix of order n, then we say that B is the inverse of the matrix A, and we use the notation A inverse to denote the inverse of the matrix. Means A into A inverse is equals to A inverse into A, which is equals to identity matrix, right? Now we are going to see some properties of the inverse of the matrix. The properties are, if A inverse exists for any square matrix, then that inverse is always unique. That is, for one matrix, square matrix, there is one and only one inverse if it exists. And when we say that the inverse exists, inverse of the matrix exists if and only if the determinant of that matrix is not equals to 0. That means A is a non-singular matrix. Obviously, we can find out the inverse of those matrices only which are square matrices, right? Then inverse of a inverse, that is A inverse inverse, is nothing but our original matrix A, and for the product of two matrices, that is inverse of two matrices A into B inverse, it is equals to B inverse into A inverse. This is another property we have. And finally we have A raised to K inverse is equals to A inverse raised to K. So these are the few properties of the inverse of the matrix. Now we will see how to find out the inverse of the given matrix. The first method we are going to see here is the inversion method, and the second method which we are going to see is the adjoint method. For inversion method, we are going to use the elementary row or column transformation. You know that there are 3 elementary row or column transformations we can use on the matrix. Which are they? First is, you can add or subtract any 2 rows or any 2 columns. That is, from first row you can add the second row, or from first column you can subtract or add third column, right? Then the second elementary transformation is, you can multiply any row or column by a non-zero number. That is, we can write it as 1 upon k Ri or 1 upon k into Cj. And third is, you can add or multiply any row or column by any number non-zero number especially, and you can add those row or column to another row or another column respectively. That is Ri plus minus 1 by plus minus k into Rj or Ci plus minus k into Cj. So by using this 3 elementary row or column transformation, we can get the inverse of the matrix by using the inversion method. We are going to see how to find out the inverse of a matrix. We have the two methods to find out the inverse of the given matrix. The first method is inversion method, where we are going to use the equation A into A inverse is equals to I. The second method which we have is adjoint method, where we find out the inverse by the formula A inverse is equals to 1 upon determinant of A into adjoint of A. So we will see how to find out the inverse by inversion method. Inversion method, it depends upon the elementary transformations, either the row transformation or column transformation. Now we have we can use the 3 transformations. Either you can add or subtract any 2 rows or 2 columns. You can multiply any row or column by a non-zero or non-constant number. Third is you can multiply any row or column by any non-constant number, and you can add or subtract that row to another row or that particular column to another column. So by using this 3 elementary row or column transformation, we can reduce our matrix to the identity matrix and obtain the inverse of the given matrix. So we will see the first method, that is inversion method. Here we will consider the example. This is the 2 by 2 matrix where we have the 2 rows and 2 columns, right. Now for you know that we can find out the inverse of the matrix whose determinant is not equals to 0. In properties we have seen that inverse can be found out only for non-singular matrices, that is the matrices whose determinant is not equals to 0. So we will first of all check what is the determinant of this matrix. The determinant is given by 4 into 3 minus 2 into 1. So here we get the determinant of the given matrix as 14, which is not equals to 0. So now we are ready to find out the inverse. So for inversion method, we consider the equation A into A inverse is equals to I. Now we will apply the row transformations on the matrix A. Here I is the identity matrix of same order, that is of order 2. Whatever the row transformations we are applying on matrix A, the same row transformations we will apply on identity matrix I, and we will apply the transformations on this matrix A such that this matrix will get reduced to the identity matrix. So here we will use the row transformation, that is R1 we will interchange with R2. So we will interchange row 1 with row 2. So our matrix will now become 1, 3, 4 minus 2 into A inverse is equals to, here also we will make the change. So we will interchange second row with the first. So second row will now become the first row and the first row will now become the second row. Now we will make use of this 1 and make the term below it as 0. So we perform the next elementary row transformation, that is R2 minus 4 times R1. So this will become 4, then 4 minus 4 will become 0, and minus 2 minus 14 minus 12, so that will become minus 14. The same transformation we will apply on this identity matrix, that is we will multiply the first row by 4 and we will subtract that first row from second. So here we obtain it as minus 4. So here we got the 0. Now we will reduce, we want this element to be 1 because we want to reduce our matrix A to the identity matrix. So here minus 14 is there, we will multiply this second row by minus 1 by 14, so that here we will get the element as 1. So when I divide it or multiply this second row by minus 1 by 14, 14 and 14 will get cancelled, minus minus will become plus, and here we get the term as 1. And the same transformation we will apply on second row of this matrix, that is the matrix on the right hand side. So this will become minus 1 by 14 and 4 upon 14. Now only one element is remaining, which we have to make it as 0, and once we make it 0, this matrix will become the identity matrix. So we will apply now the transformation that R1 minus 3 times R2. So this will become 3 minus 3, 0. The same transformation we will apply over here. So our matrix will now become 3 by 14, 2 by 14, minus 1 by 14 and 4 upon 14. So our original matrix A, by applying the row transformations, we have reduced it to the identity matrix, right. So it is I into A inverse is equals to some another matrix, and this matrix is nothing but the A inverse, because you know that identity, any matrix into identity matrix is nothing but the matrix itself. So our A inverse for this matrix is 3 by 14, 2 by 14, minus 1 by 14 and 4 upon 14. So we have seen the inversion method to find out the A inverse of a 2 by 2 matrix. We have shortcut method also to find out the inverse of the 2 by 2 matrix, and that shortcut method is, if you have given the matrix 2 by 2 matrix A, B, C, D, then we can find out its A inverse by 1 upon determinant of A. Now here if you observe these two matrices, you can find that here we are interchanging these principal diagonal elements, that is we interchange A with D and D with A, right, and we are changing the sign of this diagonal, that is we change the sign of B as minus B and C as minus of C. If you consider this example, here the first row is 1 minus 2, second row is 5 and 3. Now the determinant of this matrix, we obtain it as 13, which is non-zero. So we can find out the inverse of this matrix. So we can find out its inverse easily by using this formula. So here we interchange 1 and 3 with each other. So it will become 1 upon 13, 3, 1, and we will change the sign of this diagonal element, that is minus 2 will now become plus 2 and 5 will now become minus 5. So we have obtained A inverse as 1 upon 13, 3 2 minus 5 and 1. We can verify our answer by using the equation, that is A if you into A inverse is equals to identity matrix. So it is the this equation or this formula will give you the easily the inverse of a 2 by 2 matrix. Now we will see the second method to find out the inverse of the given matrix. The second method is the inverse we can find out by adjoint method, where A inverse is given by 1 upon determinant of A into adjoint of A. So before going for this, we will see some basic preliminaries which we need to find out the adjoint of the given matrix. We will see that if we have given this is the 3 by 3 matrix, then its elements are written in the form A11, A12, A13. So these are the elements of first row. A11 means first row, first column, so that's why it is A11. A12 means first row, second column. A13 means first row, third column. Similarly, for the second row we have A21 means second row, first column, A22, A23, A31, A32 and A33. So this is our matrix A33, A 3 by 3 matrix. Right? Now we will see what is meant by the minor of the matrix. Minor means we can find out minor of the element. If we are considering the first element, that is A11 element, then we can find out its minor by eliminating the row and column in which that particular element is present. So A11 is present in first row and first column. So we will eliminate this row and this column and we find out the determinant of rest of the elements, that is A22, A23, A32, A33. So the determinant which we obtain by eliminating the row and column in which that particular element is present, we will get the minor of that particular element. If you take the second example where we find out the minor of the element A32. A32 means it is in the third row, second column. So we will eliminate the third row and second column in which that particular element is present, and we find out the determinant of the elements A11, A13, A21, A23. So this determinant will give us the minor of element A32. So in the same manner we can find out the minor of all these 9 elements and we get the matrix of minors. Once we get the minors, we can find out the cofactor of the element. Now we will see what is meant by the cofactor of the element Aij. Cofactor is nothing but it is the minor with the proper sign. Means if we have the element Aij, that is the element is present in ith row and jth column, then the cofactor we can obtain it as minus 1 raised to I plus j into minor of Aij. For example, if you take the example of element A11, A11 is in the first row, first column, that is I is 1 and j is 1. So it will become minus 1 raised to 1 plus 1, that is 2. Minus 1 raised to 2 is a even number, so minus 1 raised to 2 is 1 into the minor of the element A11. So in the same manner, cofactor of element A32 is nothing but this element is present in third row and second column. So cofactor of A32 will become minus 1 raised to 3 plus 2 into minor of A32, that is A11, A13, A21, A23. Now the cofactor of element 32 we can obtain by minus 1 raised to 3 plus 2 into minor of element A32. A32 is, this is the element, it is in the third row and second column, so I is 3 and j is 2, and you know that minus 1 raised to 3 plus 2 means 3 plus 2 is 5 and minus 1 raised to odd number is minus 1. So this element will have the sign minus. So in the if we find out the cofactor of all those elements, then you can see that for when you plot the cofactor matrix, then in that case the element A12, A21, A23 and element A32, they will have negative signs, and other elements, that is A11, A13, then A31, A33 and A32, these element, this minor cofactor of these elements will have plus sign. Now coming to the point, that is adjoint of the matrix A. Adjoint of the matrix is nothing but it is the transpose of cofactor matrix. So whatever matrix we obtain by finding out the minors and giving the proper signs to them, if you take the transpose of this cofactor matrix, then we get the adjoint of the given matrix, and we can find out A inverse by the formula 1 upon determinant of A into adjoint of A.